Hi, you guys. If you could please fast forward to 1 minute and 57 seconds. I'm skipping the first example so you could get going. Okay, thanks. Things that have infinitely many solutions. So let's look at this one. So first, again, I always have to simplify first. So let's make sure we really reinforce that. Simplify first. So I'm going to distribute this -2 to each term in there. And I get a negative times a positive is a -8 y. And -2 times a positive 1 is a -2. And then on the other side, it's already simplified. When I have two or less terms, I know that's simplified. Now, notice that my coefficients on either side are the same. So when that happens, and I'm going to send them to one side or the other, I'm going to add 8y to both sides. And when that happens, what happens is they go away. So the only thing I'm left with is a -2 on this side and a -2 on this side. When they are identical on both sides, there's an infinitely number of solutions. Okay? So that means any number works, infinite number of solutions. Okay? Infinite. So what does that mean? So that means, let's look at 3. Is 3 an answer to this? We've been checking, and so we've understood that our answers are solutions. So let's look, is 3 a solution? So I'm going to plug 3 into my equation, my original, and I get, so first I always write the original equation. And every time I see a y, I'm going to substitute 3 for that. And I'm going to focus on one side. I'm going to simplify what's in the parentheses first. 12 plus 1 is 13. So I got -2 times 13, and I get -26. Now let's look in on this side. I have a -8, and then I'm going to replace the y with 3, and then -2. Using order of operations, I get -24 minus 2 also equals -26. So yes, 3 is a solution to that. Okay. Well, what about 1? Is 1 a solution to that equation? So let's see. I'm going to write the original equation. -2 times 4y plus 1 is equal to -8y minus 2. And every time I see the y, I'm going to substitute 1 this time. So I'm going to see, does 1 work? So let's see. And then I'm going to add that plus 1. And I'm going to focus on one side. Okay. See. So using my order of operations, I'm going to do parentheses first. Come on. Parentheses first. Negative 4 times 1 is negative 4, plus 1 is negative 3. So I know this is negative 2 times negative 3, and that simplifies to negative 6. Negative 4. Come on, come on. There we go. Now let's look on this side. I have a negative 8. Oh, yep. That doesn't work. Oh, did I write the right thing? Yep. Negative 4. Okay. So I have a negative 8 times 1 minus 2 equals a negative 8 gives me a negative 10. What should work? Where did I go wrong? Oh, it's this negative. It's not a negative. Here's my error. For some reason, I put that in. 4 plus 1 is 5, and that gives me a negative 10. I apologize. And this is also negative 10. So that means 1 is a solution. So no matter what I would try, it would always be a solution. So that's what it means by infinite solutions. So I want to fix this one here. Could you make that a minus 4? Okay. So now let's look at this one. Again, I'm going to simplify each side. The left side is already simplified. And the right side, I have negative 3 times a negative 4 is 3x. Sorry, negative x. And a negative 3 times a negative 4 is a plus 12. Focus on notice that the coefficients are the same. Well, if I subtract 3x from both sides to make sure they're on one side, they both will disappear. And I'm left with 12 equals 12. Again, that's a true statement. So I know I have an infinite number of solutions. Okay? When my variables cancel out, and my constants are the same, I will have infinite number of solutions. So my coefficients are the same, and my constants are the same. I will have an infinite number of solutions. Okay, what about no solution? Is there a case when we have no solutions? Yes, there is. So first I have to simplify. Okay, when I have something that has no solutions, that means nothing works. So I'm going to first distribute, and I'll show you what it would look like. 3 times 5 is 15x, and 3 times 2 is 6. And the other side is already simplified. If I notice that my coefficients, oh, that's an x, are the same. Sorry, I'm making my mistakes with my negatives. I don't know why it keeps crossing out. Anyways, I'm going to subtract 15x from both sides. And that goes away, and that goes away. And the only thing I have left is a 6, and on this side is a 0. Okay? This is a false statement. Okay? So that means there are no solutions whatsoever. When I have a false statement, no solutions. Look, not this one. I'm going to distribute, and I get negative 3x plus 6. And on this side, it's already simplified. Now I'm going to focus on those coefficients. Well, they are the same. And notice that the constants in this one were different. These are different. And this one was different. So this one was plus 6, and that was a 0. So I'm going to add 3x to both sides. And the only thing left are my constants, and I get 6 equals 4, and that is a false statement. So that means there is no solutions. Okay, no solutions. Okay, so when we're looking at an equation, nothing works when I have no solutions. So my coefficients are the same, but my constants are different. So those were real key components, okay? So here I have a graphic organizer. When I have one solution, I end up something like this. The variables stay, okay? They're not eliminated. When I have no solutions, the variables are eliminated, and I get something like 7 equals 9, and that's a false statement. When I have infinitely many solutions, the variables are eliminated in the equation, and a true equation is left, something like 12 equals 12. So this would be an infinite number, and this is a true statement. 12 does equal 12. So here there's a really good, here I kind of solidified everything for you. If I have one solution, I'm looking at the coefficients. Notice they are different. Key piece to that, because they will not cancel out. Okay, they are different. When I have no solutions, notice that focusing on my coefficients, they are the same. So I'm going to write these are the same. But my constants are different. These are different. And sorry, my writing, I'm trying to rush through this. When I have infinite solutions, my variables go away and I get something like this, and that's a true statement. What I'm looking at is when I look at those coefficients, they will be the same. So I'm going to write those are the same. And my constants are the same. Everything goes away. And I get a true statement, and that is also the same. Okay. You will be asked to create equations that have no solution, one solution, infinite solution. Use your graphic organizer to help you. So looking at no solutions, I'm going to focus on my coefficients. So if it has no solution, I'm going to look up here. This is no solution. My coefficient has to be the same, but my constants are different. So I know this is going to be 2x, and my constants have to be different. So I'm going to put plus 2. One solution, well, looking at my graphic organizer, my coefficients have to be different. So I'm going to write 3x plus 2. Do 7. All right. Infinitely many solutions. Okay. It says my coefficients are the same and my constants are the same. So I have 2x plus 5 because my coefficients are the same and my constants are the same. Okay, that's what we're looking at. Now, create an equation that has no solution. Looking at this, I first have to simplify first. Okay, 4 times 2x is 8x. 4 times plus 3 is 12. So I really want to look at what kind of equation that is. So if I want no solutions, I'm looking at my coefficients, looking at my graphic organizer. My coefficients are the same, but my constants are different. So I know this could be 8x plus 12, different. I'm going to put 10. One solution, well, I know my coefficients have to be different, so I'm going to put 3x minus 2. Doesn't matter what my constants are. So infinite many solutions, my constants and my coefficients and my constants are the same. So I'm going to write 8x plus 12. So they have to be identical. This 8x has to match that, and my constants have to be the same. Okay, thank you.